Okay, let's do problem 130, surrounded regions. Here we're given n by n matrix board containing letters X and O. We need to change some blocks of O's that are fully surrounded by X to X, just like Game of Go, and the others remain unchanged. So there are two cases. In the first case, this block of O is fully surrounded by X. When we say surrounded, we are only considering the horizontal and vertical X. We are not considering the diagonal ones, as we can see in green. So since it's fully surrounded, they need to become X. And there's a second case. This block of O is touching the boundary. So when it touches the boundary, it can never be fully surrounded because we're missing one at X here. So this block remains unchanged. So we're given this input and we change the 3 O's to X, and then this O remains unchanged. So what's the conceptual solution? We need to find all the blocks of O's that are touching the boundary and assign a new letter. In this case, I gave it hash, but it can be anything. So if that means after we changed it to this format, all the O's are surrounded by X. So we can simply change O's to X and then hash to O. So let's put conceptual solution to code. So we need to change the blocks of O that are touching the boundaries. To do this, we need to check if the elements touching the boundaries are O. And in 2D array, there are two boundaries, vertical and horizontal boundaries. For the vertical boundaries, we're going to iterate downwards like this, and then we're going to use index of 0 and index of n minus 1. So for our code, we need to introduce our variable m and n, and then we need a for loop that goes through vertical boundaries. Likewise, we need to go through horizontal boundaries using index of 0 and index of n minus 1. So we need another for loop, this. So the question is, what are we doing during these iterations here? We need to perform DFS, but the question is, why DFS? So let's consider this example here. So whether we do it horizontally or vertically, we can see that the first element contains 0. So ideally, we want to change all the adjacent cells that are containing letter 0 to hash. But before that, let's come up with a function that changes the current element to hash. So we need a private function for this one, and a very simple board row call is equal to hash. So we change the first one to hash. Now we need to recursively call this function. But the question is, how should we call it? Well, we can call it down, we can call it up, we can call it to the right, we can also call it to the left. So we're essentially calling in 4 directions. So we need to recursively call this to the right, left, top, and bottom. And our function will look like this. But when we look at it, if we call it to the top or to the left, and if we change both row and column to hash, it will throw error because they are out of bound. So before this function is called, we need to make sure that it returns back to the original position. So we essentially need to check the boundaries. And when we look at this one is not equal to O. So it should also go back to the original position. So the only direction we can call it is down. And then from this point, we can recursively call the same function in 4 directions, and then it will eventually change all the adjacent cells to hash. So we need to apply a line of code that can stop our recursion. So we need to check for these 4 boundary conditions and then 1 condition when it's not equal to O. So to do that, we need to do this. So introducing M and N here, and then we are stopping our recursion when any of the conditions are satisfied. That's great. And then by the end of our DFS call, all of the cells would have changed to hash. So we need to call DFS in all of them. So it will look like this. Now what we need to do is very simple. We need to change all the O's to X and then hash to O. So it's a very simple nested for loop. So it will look like this. And before we run our code, let's add one last thing, which is edge case. So when the board is null or the length of the board is 0, we don't need to do anything, just return. So let's run the test. Let's submit. All right, that's it.